Theorem 12, let ABC be a triangle if the line L is parallel to BC and cuts AB, so that the line segment AB in the ratio of, I don't know, 3:2, whatever, S:/D, then it also cuts AC, that line segment, in the same ratio. So this should make a bit more sense if I actually hopefully draw it, but that's what you'll be given in the exam. Again, it's deductive reasoning, so every time you make a statement you must back it up in your proof. What were you given? Well, it's all here, written in English. You have to just write it mathematically. What are you trying to prove? Again, all here, written in English. You need to do it mathematically. If there is a construction, you need to just inform them. And then you go on to your proof. This is a nice short one. I'm going to draw my triangle best I can, because I was given a triangle ABC. So that's not an isosceles triangle. I reckon that side's a little bit longer than this one. Doesn't matter. Just letting you know, I'm not purposely drawing any particular type of triangle here. A, B, and C. So there's my triangle ABC. And they've told me the line L that's drawn, that's parallel to BC. So I'm going to draw in a line L that's parallel to BC. Here and there. So there's my line L. I'm going to mark in that it's parallel to my base, because I was given all this in the question. Oh, sorry. This is just okay. And they have told me that the lines are cut in the same ratio. That's all. So what was I given? I was given a triangle. I've named it A, B, and C, as they have said. And a line, might as well name that line, they've called it L, but if you notice here, it has made kind of cut AB here, and it does talk about that, cutting AB, so I might as well talk about where it cuts AB. Again, doesn't matter what you call it. So, triangle ABC with a line XY, and that line is parallel. I mean, you can write the words if you want, or I'm just going to do the symbol. Parallel to AB, no, BC. Oh my God. So parallel to BC, and it cuts AB, that line segment, in the ratio of S:/T. So that's exactly what I've been given. What am I trying to prove? Again, it's written up here, but I'm trying to prove that AY and YC will be in the same ratio as AX and XB, but that's just the ratio of S:/T. Be the exact same ratio. I wouldn't learn any of that off. As I've said in the previous one, you need to just get familiar with doing this, reading what you'll be given in the exam, drawing your diagram from this information, writing this from your information as mathematically as you can, and this also. Again, construction you might have to remember. So maybe this is the only part where you'd want to have it kind of stored as to what you're going to do. And you're going to divide AX into 5 equal parts, 7 equal parts, 9 equal. I can't do that. I need to have algebra here, so S equal parts. So we're going to divide it into S equal parts, and then you're also going to divide XB into maybe 2 equal parts, 3 equal parts. You can't say that though. It has to be a mathematical proof, and proof requires algebra. So this is going to be divided into S equal parts, and this bit here is going to be divided into T equal parts. But S and T are just stand for numbers. So I need to write that. I'm going to divide AX into S equal parts. And I want to divide XB into T equal parts. And then I'm going to connect that over to the other side. So how will I say that? I guess maybe it's important to state here as well. I don't think it states it in your book, but you know, each of these, like, I'm just going to divide them up here a little bit so you can see. But they look equal. Where S and T are equal to each other as well, just so you know. So you may want to put that information in, that, you know, this little bit here. So this might be divided into 1, 2, 3, 4, 5, 6, 7, 8. And this might be divided in 1, 2, 3. So it might be in the ratio of 8 is to 3. Now S is to T. You know, I'm not really counting that, but I'm just letting you know what I'm doing here. That these are equal to each other. That the S and T, that the length of each of these segments here are equal to each other. So I would put that in just to explain it. So divide AX into S equal parts and XB into T equal parts, where each part is the same length, maybe. And then I want to join each point and draw a line parallel to BC. So I need to draw a line from each point parallel to BC. Hope again that that's okay. Let me just do that. I'm gonna not use a ruler, which is not good, but I'm just gonna do this quickly. Now, here's my proof. So, according to Theorem 11, the parallel lines cut off equal segments. So Theorem 11 is the one that we just did. Sorry, I'm just going to go back to this. And according to it, the parallel lines cut off segments of equal length along AC. So let K be the length of each of these equal segments. Does that make sense? So each of these segments is of length K. Maybe I'll just put it here. So theorem 11, maybe I don't even need Theorem 11, parallel lines cut off. Segments. Let's call it K. Doesn't matter what you call it. Yeah, maybe that is saying it, but I guess I'm going to be absolutely sure they understand that I know what I'm doing. So the length of AY now is going to be sorry, I put the K in the wrong spot. So I do actually think this bit is necessary here, where each of these is the same length. So I'm trying to say that each of these are the same length. All the way down. K is the length over here. When you've divided AC up, let K be the length of each of these equal segments that have cut up AC. So I shouldn't have put that there, it's over here. So this is necessary here. Right, so AY is equal to S times K. Think about it. If there's 8 here and they're all 2 in length, that means this is 16. And YC is T times K. Again, if there's 3 of them and they're all K in length. So that just implies, this is really short, AY is to YC is equal to SK is to TK, which is just S is to T when you bring that down to its lowest form.